Okay, so we had canceled this. We were looking for g of x. So we have g of x. We have our -2 over x minus 1 plus 5. We're getting to the same form as the long division, so on the test, I don't care how you do it. Okay? Either way, whichever way is easier for you. Alright, and the question it also asked us was rewrite the function, graph it, so we're not graphing on this section, and then describe the transformations. So we're here, and then we're going to describe our transformations. So what does our denominator do for transforming? Right 1 and up 5. That's all we're doing on those.
I'm still not like
I feel like the other way is more efficient. Right? Is that how you like? I feel like the long division's better.
yeah.
Yeah, me too.
I mean, it's also reflected and stretched by 2.
Yes,
Because
yes. You're not okay without all of the transformations being listed?
yeah.
Alright, let's do one more of those. 33, 35, 37. Pick one.
37.
37.
Yeah, let's go 37.
Sure.
Okay, I also feel like we need to do 35. We'll do 37 first, and then go back to 35. Alright, 37, 3x plus 11, x minus 3, is that correct? Yes. Alright, so we're going to substitute our denominator into our x in our numerator. And we need it to be plus 11, so if we're thinking about what this is,
-9.
3x minus 9. I need it to be
20.
positive 11.
Add 20.
So we're going to add 20. Okay, everybody good with getting to the plus 20?
Why did you get to the plus 9?
Okay, so if I were just looking here, I have 3x minus 9, right? I'm here,
Yeah.
but I need it to be at 3x plus 11. If I'm at minus 9 and I need to get to positive 11, if I add 20, and put our like terms together, we're at positive 11.
Oh, did you just multiply the bottom by 3?
No.
This part I didn't have here. We substituted in the denominator into our x. So we took this and put it in here.
So you multiplied it by 3, basically.
No. Same.
I'm confused.
We replaced this x with our denominator.
Oh, okay. Now I'm seeing.
And then if I
got you.
distributed my 3, I needed to get to positive 11, and I was at negative 9. So I added 20. Okay.
Alright.
You're good. Alright, so we're here. On the top, we're going to separate those out. So I now have 3 times x minus 3 over x minus 3 plus 20 over x minus 3.
Cancels. You get 3.
This is canceling.
Which, if my calculations are correct, is exactly what you get if you divide them.
It is. Yeah, if you want to check it, you can. Do it the way we had done previously, because long division, we were here. Asking ourselves x times what gets us to 3x. So we have 3x minus 9. Change our signs. We would have 20. So remember here, we wrote it as 20 over x minus 3 plus 3. Getting to the same place.
That was way easier.
I agree. I agree.
Can I write that
Yep,
down?
you can write this down. This was how we did it in 7.3.
Hey, Miss Winry.
What's up?
Come here.
Mm-hmm. And then what were our transformations on that?
I did, okay, we did this one, you know,
Uh-huh.
and I tried to do that, we did negative
And
3.
for the stretch by factor of 20.
Five,
who cares about
five
that,
x minus five, because you're multiplying these. X times 5 is 5x, negative 1 times 5
Oh,
is
okay,
negative
okay,
5.
I did.
And then change your signs, yep.
Okay.
Alright, so our transformations were right 3 and, what does this 3 do? Up 3, right 3, up 3. We good? Let's go back and look at, what number did I say?
35.
35, just because they throw a little kink in, and they give us something different. 35, we have 2x plus 3 over x.
Isn't that easier?
It just messed with my brain a little bit. If we're putting our denominator into here, this stays looking the same, right?
There's two.
2 times x see, it's messing with my brain right now. We don't have to do anything except separate it out. We're already on the second step, aren't we?
Yep.
Yep, we can just do this. Yeah. And then we can cancel these. So this one was easier, it just, I remember it being different. And what's our transformation on that guy? Nothing here, right? Just been moved up two.
Imperfectly stretched by 3, but who cares about that?
Alright, they're just saying this is our parent function, Sam, like 3 over x would be our rational parent function. And what's the transformation that's happened from that parent function, is why they're not asking you to list it.
Okay.
Yeah, I agree, I mean, it does change what it graphs like, but since we're not graphing it, we aren't seeing it as much. Alright, are we good with that section?
Yeah.
Alright. Last kind of problem. Okay, 39. Do what?
What's that supposed to mean?
It's the last type of problem, and it looks scary,
Oh, it's really scary.
and
I don't like it.
we love fractions.
What?
We love fractions.
No. Bruh.
Okay.
You can't be doing this to us.
She can. And
All right.
she is.
These are called complex fractions, so they're fractions within fractions. Okay.
I'm pretty sure.
To solve, we're gonna multiply everything by the least common denominator and then simplify, okay? So we have to look at the fractions within the fractions and look at those denominators and find our least common. All right, so we have x and we have 3x, correct? Okay, so every term is gonna be multiplied by our least common denominator, but between those two would be what?
3x.
Would be 3x. All right, I'm gonna rewrite this.
Mega oof.
We're only doing 2 problems like this, children. Only doing 2 problems. Alright.
Ultra.
Okay, so if we're looking here, I'm gonna go ahead and cancel what I can. Right now I have a 3 on the top, 3 on the bottom. These can cancel. So my first term is x squared minus 18x over 10 times 3x
30x.
plus, okay, I'm gonna go ahead and cancel what I can. I have an x on the top, x on the bottom. I'm gonna cancel that.
12.
Okay, do we see anything else we can do to simplify?
You can factor out
So 18.
3.
Yeah, okay, so we can,
Or
what can we
6.
factor out on the top
Yeah.
in our
X,
numerator?
X.
An x. And what can we factor out in our denominator?
6.
6. At this point, sometimes things cancel. Okay, nothing is canceling there.
Yeah, no.
Oh, that's the answer?
That's
it?
the answer.
Okay.
That's
Thank
the answer.
goodness. I was like, I don't want to do any more.
Okay, do you see any restrictions that happen because we cancel things?
3.
No. X can't equal 0.
Okay, anytime there's a variable in our denominator that gets canceled, we have to set that up to equal 0. So there is an x here, we have to set that up to equal 0, so our restriction is x cannot equal 0.
Mm.
One more. One more. Okay. Are we good?
We're fantastic, Miss Mary.
Sure.
We're great, aren't we? Alright.
I'll pretend that that's the answer.
41. 44 I assigned as bonus, so. there's
Yeah,
that.
I'll certainly attempt that.
43 I was attempting last night, and I was like dozing off, and so I would doze off, and then I would like look at it and be like, oh, I don't know what's happening. So, good luck with it. Do it while you're fresh. You should do it first. Alright, the first thing we have to do is find that least common denominator. Alright, well we have 1, 2, 3, right? Alright, so I see 2x minus 5. Let's work with this one and see where we are. So 8x minus 20. Alright, what if we factor out 4? We have it as x minus,
That's 2.
yep, it is. Thank you. 2x minus 5. Alright, 2x minus 5, 2x minus 5, and then 4 times 2x minus 5. These are our 3 denominators, right? 1, 2, 3.
Yeah.
We need to include this once. We don't have to include it again. And we need to include this once. So our
So 8x minus 20.
least common denominator, we're gonna leave it as 4 times 2x minus 5. Do it?
LCD nails.
Oh. I laughed really hard at that one the first time I heard it. Okay. So what do we need to multiply this term by so that we have our least common denominator here?
Times 4?
Times 4. What do we need?
Wait a minute. Not at all how you solve the
We can do
previous
this.
one.
We can do this if that makes you feel better. It's fine. Our denominators are all gonna cancel, whether we write them all out or not.
I will take your word for that.
I promise it's a thing. Okay, so here we don't need to multiply this by anything because this is actually 4 times 2x minus 5. Right?
Mhm.
That one's good to go. This one needs to be multiplied by
4 again.
4. Alright, so that makes all of our denominators the same. True?
Now it does.
Look. Yeah. Okay.
That's not how you solved the last
It's
one.
not how it was set up. We can do it over 1.
Can we though? Why?
Why do you keep changing it?
Because I'm having difficulties.
Well, stop it.
Well,
because
I'm-
it's confusing me.
I'm sorry.
Thank you.
Okay. So up here we have 4. Okay, if you think about it as multiplying it by 4 over 4, it's by multiplying it by 1. But it's making our denominator what we need it to be.
Okay.
Okay, let me explain why we did it differently than. Okay, last time we were multiplying by 3x over 3x.
I'm just.
If we were splitting it into the numerator and denominator, it's 3x over 1 and 3x over 1. I wish I would have erased it. Okay. Let's multiply. We're going to do it by 4, guys. 4 over 4, so you guys can see it.
Okay.
Crazy winnery today. All right, 4 times 2x minus 5. Minus, nothing had to happen to it. I should have written the other one differently for you. I rewrote this one, factored out. These, I just wrote as is. Remember when you have fractions stacked, the denominators can cancel, the numerators can cancel, or simplify, I should say simplify, not cancel. So these are all gone, because they're all the same thing,
Okay.
okay?
I'm good for so far.
Alright, so really on top we have 4 minus 7 over 4x. Yep. Sammy's gonna come do the next one for us.
Is he working 43?
He's working 43 for us.
Nice.
Alright, do we have any restrictions?
That's the biggest one.
That one problem, 8x minus 20? Or do we
What
just
was
solve for
included
2x
that
minus
had
5?
it, that had variables that canceled? Our 2x minus 5, right?
Okay, do we?
That's what
include-
canceled. So we're gonna find our restriction by saying 2x minus 5 equaling 0. 2x equals 5, x equals 5 halves. So our restriction is x cannot equal 5 halves. I should have written 3x over 3x in the previous problem. It may make it makes more sense to you. To show you that those cancel. Okay? Alright. I did assign number 46. It is a word problem. It's not hard. Do 46. Don't be scared because it's a word problem. It's one little part. Not terrible. Maintaining mathematical proficiency, look at those really quickly.
I understand. I understood it. Okay, wow.
Here, you understood?
Yeah, I understood what you did on the previous one and why it's different from this one. I understand now.
Okay, cool.
Took me a little bit to
Okay.
understand.
Awesome. All right, so on the maintaining mathematical proficiency, it's asking you to solve by graphing. Look at 58. 58, you have two equations there. You have y equals x squared plus 6 and y equals 3x plus 4. How do we graph that and solve it? We what?
Where it intersect?
Where it intersects. So you're going to graph that parabola, that x squared plus 6, and that line, that 3x plus 4. Find the points where it intersects. One or two places. If it doesn't intersect, then how many solutions do you have?
Zero.
None. No solution. So on 60, they don't have it solved for you. So that first one on 60, you're going to need to solve it into y equals first.
Yes.
Okay? And then I think Desmos is easiest on that. I mean, it's giving it to you in decimals on Desmos. These may give it to you, your graphing may give it to you in fractions. Either one is fine. I worked it both ways. I didn't get out my graphing last night. I did Desmos when I tried them. Okay, so your homework is I'm gonna write it all together even though we assigned part of it yesterday. And then we're gonna do 44 as a bonus.